Okay, looks like it's time for us to get started. Before I get started, I have a strange request. I do this for every session. I have reading glasses and I need to put them on in order to do my demos, and I take them off to present, and half the time I leave them behind. So if you're talking to me afterwards, please say, hey Ben, do you have your glasses with you? Anyway, with that out of the way, hello everyone. Thank you for coming along. I'm Ben Armstrong, Program Manager on the Hyper-V team, also known as Virtual PC Guy, where I've been blogging under that name for a long time now. How's the show going? Is it a good event? People happy you're here? Now, this is end of third day, which means you're probably right on the edge of your brain turning to mush. Yep, you know, and I do feel sorry. I will put a plug out. We do have a Hyper-V session tomorrow. The Hyper-V replica guys are going to be here talking about their stuff. I do feel sorry that they're on the fourth day when people can barely figure out how to get coffee to their mouths. So my goal today is to make sure that by the time you leave, your brains are mush. I'm not going to go softly on you. So I'm here to talk about a very long session title that I'm not particularly fond of. Unfortunately, the marketing team came up with this. My proposal was how to move VMs around. But they didn't like that. They wanted this long title. So with that, I'm going to put the one slightly marketing deck up here, and I promise that after this slide, it is going to just be technical jargon for the rest of the session. I promise. Now, little show of hands. Some of you may have heard, who's heard, something about Windows Server 2012 being about cloud? Yes. Well, I feel kind of bad because you've probably heard it far too much by now. And however, I'm here to talk about virtual machines and about how to move virtual machines and how to build dynamic environments with virtual machines, which is the basis of a private cloud solution. So I do have to kind of point that out. And of course, we have been focused on private cloud a lot in this release. And one of the things that we did on the Hyper-V team, I'm actually going to walk down off my podium. One of the things that we did on the Hyper-V team was we looked at, hey, we've got live migration with Windows Server 2008 R2. It's great. It allows a lot of flexibility, a lot of mobility. People are using it. But what can we do to raise the bar? You know, where are the places where we are failing to deliver on the promise of, hey, virtual machines are easy to move around? You know, and how can we address that? And right now, we're actually feeling pretty good about what we've done in Server 2012 around virtual machine mobility. So with that, live migration, the obvious thing. Though not the only thing with virtual machine mobility, as you'll see by the end of this session. Live migration. Hopefully, you've all already seen the demos of shared nothing live migration without infrastructure. Now, one thing that I will chastise my colleague Jeff a little on is that he likes to get up on stage and say, you can do live migration with just an Ethernet cable. And I like to say that that's both too little and too much. So it is too little because the one thing that is missing out is that we do require you to have a domain environment in order to do shared nothing live migration, and both Hyper-V servers need to be in a domain. And it's also too much because I have successfully live migrated virtual machines over wireless. That does work, so you don't even need the cable. In fact, when they gave me one of the slates that we gave out at the build event, and a day later I successfully live migrated a virtual machine from my laptop to my slate over wireless, and did not drop network connectivity in the process. So, as I said, both too much and too little. You do need Active Directory. You don't actually technically need the wire. But the way this works, the shared nothing live migration, you basically have two Hyper-V servers without any shared infrastructure, no SAN, nothing involved, and we get the virtual machine from A to B. And I'm about to spend a bunch of time talking about how we do that, but before I get to that, I have to explain a bit of the philosophy of live migration, and in the process, explain why I love the job that I have. So I'm a program manager, and program managers go out, we talk to customers, we figure out what you need, we go back and we tell the development team, hey, here's what we need to build, and then we manage the project, which kind of means we get to set the bar and then yell at the developers when they don't meet it. Which also means that if you like being a program manager, one of your secret joys is making developers suffer. And one of my favorite ways of making developers suffer is when I can find a simple statement that is really hard to argue with, but makes their job all the harder. And when we started working on live migration in Windows Server 2008 R2, I came up with one of these simple statements. And I said, and I put this in the formal spec, and everyone kind of sat there and nodded and went, he's right, but that's hard. I said, you know, if someone tries to live migrate a virtual machine, and if something goes wrong, no matter what it is, no matter what happens, at the end of the day, we have to guarantee that that VM is running somewhere. Seems reasonable? You know, we have to be able to say, okay, you can sit down and try and live migrate this virtual machine, and either we're going to succeed, and it'll be running where you asked it to be, or it'll fail, it'll be running where it was before. But there should not be any scenario where we drop the ball so badly that that virtual machine's just not running anymore. And we have worked really hard to maintain that promise, even with shared nothing live migration. So even without shared storage, we're still holding ourselves to the bar of the virtual machine must be running somewhere at the end of the day. So what does this look like from an architectural point of view? So I have two Hyper-V servers, no shared infrastructure. I've gone to Hyper-V server 1, and I say, I want to live migrate this virtual machine from here to there. The first thing that happens, we establish a TCP connection between the two servers, and we perform some initial negotiation. See, hey, like, is this guy authorized to, do Hyper-V stuff on both sides? Are we running the same version of Hyper-V? Have they turned on the ability to do live migration? A bunch of basic stuff like that. Once the initial negotiation is complete, we then establish our live migration connection. And this is a TCP socket, and this is actually the same live migration connection that we use for live migration inside a cluster or outside of a cluster. Once we establish that, we actually then put the traditional live migration process on hold for a moment. And what we start doing is actually a storage migration of sorts of the virtual hard drive. And I'll talk more about storage migration later in this session, and you'll see how it's different to what we do here. Because what we actually do is, while the virtual machine is still running on Hyper-V Server 1, we copy all the data for the virtual hard disks across, and we get them into a storage mirror. We get to the stage where the virtual hard drives on both sides are identical, and incoming writes are going to both sides. And this is key, because by maintaining this mirror is how we're able to live up to the promise of, if something goes wrong at any stage, the VM will still be running somewhere. So we set up this mirror, we maintain it, and once it's in place, then we basically do a live migration like we would traditionally in a cluster. We go through, we iterate over the memory pages, we copy the changes across, we do change tracking, so on, and we do a classic live migration. It's just that instead of having shared storage on the back end, we have this storage mirror. And we maintain the storage mirror until we have confirmed that the virtual machine has started successfully on the destination side. Once we know that the virtual machine has started successfully on the destination side, we will break the mirror, and then we go back and we delete the virtual hard drive files. But the key thing is, even if we fail at that last step, we can still fall back to running on the source computer. And so this is really key. And I will apologize. I am going to spend some time in this session pointing out where we're better or worse than our competition. And I don't like to talk about VMware too much. I prefer to talk about Hyper-V. But this is something we discussed, was like, hey, VMware will say, we can do this. We can do a storage migration, a storage vMotion, and a standard vMotion. But because they haven't integrated it into a single operation like this, when they do it, there is a window of risk. If you move the storage without moving the VM and you then have a problem, then you're going to be in a lot of trouble from what's happening with the virtual machine. So let's demo this. What does this look like? I'm going to switch across to my demo environment. Before I do the demo, I will explain a couple of things. This is actually a relatively big, complicated demo environment for me. So a few things to know. The first thing, this may or may not surprise you. There are a lot of computers at Microsoft, and we have problems with people having conflicting computer names. So it's actually, it's not an enforced policy, but it's a general polite practice that we always name our computer names with our email alias first. So you'll see all my computers are named benarm-something. The second thing to point out is that a long time ago, in another lifetime, I actually went to university and studied applied science in mathematics. If you want to talk about statistical analytics, it's a personal passion of mine. And with that in mind, when I had to name a set of computers, of course, I looked to the Greek alphabet. So my demo computers are benarm alpha through theta. And specifically today, I'm going to be using alpha, beta, gamma, delta, and epsilon and zeta. So the first set of demos are on epsilon and zeta. And epsilon and zeta are just two standalone computers using local storage. I am paranoid about typing the wrong thing in demos, so I actually go as far as making sure my storage is configured predictably on these demos, and this does cause some confusion for people. So I'll just point out the way I have the storage configured, all local storage, but my system drive is the G drive on all my systems. On most of my systems, all my virtual machines and data are stored on the J drive. Zeta is special. He has a second data drive, which is the K drive. So today you're going to see the J drive and the K drive a lot as I'm stepping through things. That's just partitions that I've done consistent naming of. This table is not working for my mouse, so I'm going to have to use my trackpad. So let's get going with the shared nothing live migration. So I'm going to start up a little workload here. I've got two things running here. I've got a ping and I've got a file copy. And I'll explain why I'm doing both of those later on in the demo. But let's just move those down the bottom. And I'm going to be doing a migration of file server 1. Let me position this. And you can actually see here I've got file server 1 selected, running on benarm zeta. And I've got the networking tab here, so you can see this virtual machine is using 209.111, which is what I'm doing the ping on, and what I have the file copy going on. And I will bring up the settings for this virtual machine. And just to show you that it is configured using local storage. So it's stored on my J drive, nothing shared. And I'm going to move this virtual machine over to epsilon. To do that, I'm going to come into a Hyper-V Manager, start the Move Wizard. I'm going to say I want to move the virtual machine to benarm epsilon. I'm going to choose the easy option and say put everything in a single folder, and in the J drive on benarm epsilon. Now I'm going to start this. Now this is going to take a little while, and I will warn you as you're watching this dialogue, I love my developers very much. They're great at doing complicated things like shared nothing live migration. They are not so great at doing consistent progress dialogues. So when this dialogue gets to about 30%, it's actually at about 90%. So don't worry if you're watching this and you're seeing it kind of crawl through the first couple of percent and going like, how long is this going to take? So At this stage, this virtual machine is still running on Ben Zeta, and what we're doing right now is we're setting up the storage mirror. We're copying the data across and setting up the mirror. And once the mirror is established, then we're going to move into the live migration phase. And from a progress bar point of view, that's actually the 50%. When the progress bar hits 50%, we're done with storage and we're doing live migration. The reason why I have both the file copy and the ping going for the workload here is we've designed live migration so that when we move the virtual machine, there is a downtime, but it's designed to be under the TCP/IP timeout of 5 seconds. Now, what we'll see is that the file copy is not going to be interrupted because it's using TCP/IP, and it has a safety threshold in there. Ping uses ICMP, and it's designed to detect very small outages. So when the live migration happens, we should hopefully see 1, maybe 2 pings dropped, and the file copy complete. So we're at the magic 50%, so we're now doing the live migration. The storage is over there, and in a moment, we'll see a dropped ping or 2. Let's see. I always like to try and guess how many pings I'm going to drop, but I never say it out loud because I'm always wrong. So we had 2 pings dropped, the file's copied, and the virtual machine is now over on Ben Epsilon. I think that's pretty cool. Let me close these windows. Otherwise, I'll forget them later on. So that was shared nothing live migration. And even though I showed you UI, everything in the Hyper-V UI is supported in PowerShell. And I really like the migration commands because, as you can see, they're incredibly complicated. So this is all you need to type into PowerShell. So move VM, the name of the VM, the server you want to move it to, include storage, destination storage path. That's the PowerShell command to do the same thing that I just did in the UI. So that's one new form of live migration. But another new form of live migration that we've added is also live migration using SMP. So here, what we allow you to do is we allow you to have a virtual machine that's completely stored on an SMB share. And you can now, you can set up a cluster using SMB and get that. But if you don't care about high availability and you just want to have quick mobility, you can live migrate that virtual machine around. And you actually get exactly the same experience live migrating a virtual machine on an SMB share that you do for live migrating a virtual machine in a cluster. So the catch here, however, which I do have to go through, is that setting up the SMB share for this is quite a pain. This is something that I really wish that we'd done a better job of, and we had serious discussion on the team about what can we do to make this better, and it did not make the cut for improvement. So the challenge is, there are 2 challenges. The first challenge is you need to set up your SMB share so that both the user account for the person who's going to be doing the migrations and the computer accounts for all the Hyper-V servers that you may migrate the VM to have access. The second challenge I will talk about in a moment. Because what this looks like is you've got your SMB share, and you need to do this both on the file security and on the SMB permissions. And you need to go through advanced sharing, permissions, and add your accounts. And similarly for file permissions, advanced sharing permissions, and add your accounts. So what's the second pain point? The second pain point is this. You're going to hit add on this page, and it's going to bring up this, and you're going to type in your computer name and hit OK, and it's going to say, I have no idea what you're talking about. Because this default dialog does not include computer objects. What you actually need to do is come here, open object types, check computers, then go back, then type in your name. And unfortunately, the error message that comes up here does not say, hey, maybe it's a computer object. It just says, I don't know that account. So that one I am looking forward to receiving support calls on. No, I'm not. But I know we are going to receive support calls on that. Ironically, I actually think this one's easier to do from PowerShell. This is the PowerShell command that I did to set up my file share. So that sets up both the file permissions and the SMB permissions and creates the SMB shares. So as I said, I think this one was actually easier to do from the command line than from the UI. So let's do a very quick demo of this. And this one is going to be a very quick demo because, once again, to highlight, in this one the storage isn't getting moved. The storage stays exactly where it is on the SMB server. And it's just the running virtual machine that gets moved. Move that down. I will quickly bring up the settings for this so I can just show you that the virtual machine is running on SMB. No smoke and mirrors. So here you can see I've got file share on BenArm, Ada, SMB share. That's where the virtual hard disk is stored. And I'm going to use the same wizard again. I'm going to move the virtual machine. I'm going to move it to BenArm Epsilon. But this time, what I'm going to select is that I want to move only the virtual machine. I don't want to move the storage. Which has, once again, great example of progress bars. We jump straight to 50%. But there, that quickly, the virtual machine's moved across. Let's see how many pings we drop. 2 pings again. We're being consistent today. So there we go. My virtual machine's moved over very quickly. So let me close those. We'll jump back. And here's the hardest PowerShell command you're going to see at this show, I am sure. If you have a virtual machine that's on an SMB share, this is how you move it. I love this command. Move VM, name, server, enter. So live migration in clusters. So I've been talking about all the cool things we've done for live migration outside of clusters. But we've also done a lot to benefit live migration inside of clusters. So people like live migration inside clusters. So we've done a lot of things. We've done a lot of work to make live migration, both inside and outside of clusters, faster. Live migration will now saturate a 10 gigabit connection to get your VM over there as fast as possible. We have added support for concurrent live migration. Before you ask, we're still working on the guidance about how many we're going to support. What I'm expecting is that we're not going to come out with a hard limit of we only support X concurrent live migrations, but I'm expecting we're going to come out with a statement of you need this much bandwidth per live migration. And however much bandwidth you have, that's how much it works. And right now, unconfirmed, our testing, I think we're going to end up saying 500 megabit per live migration. So that's probably where we're going to end, but that's not official. So we've done a lot to make live migration in clustering better. But one of the really cool things that we've allowed in this release is the ability to live migrate a virtual machine between clusters. So you can now have multiple clusters. You can be live migrating inside a cluster, but you can also live migrate between clusters. And I'm actually going to demonstrate that today. So let me flip across, and I have to use a different demonstration system. By the way, I've been doing the BenArm Zeta that I've been doing this demo on is our min server deployment. So you'll have noticed I had the nice black desktop with a command prompt, but I had the Hyper-V tools. I'm now going to use BenArm Theta as a full installation of Windows Server, but I'm going to be using it to remotely manage 2 clusters that I have configured. I have BenArm Alpha and Beta in a cluster, and BenArm Gamma and Delta in a cluster. And those boxes are configured using just a server core, so I'm going to be doing this all remotely, assuming that it ever logs into the system. So while we're waiting for this is the joy of connecting overseas. These systems are all in a lab in Redmond. Oh, there we go. They've come up. So here I have my 2 clusters. I have AB is the alpha beta cluster, and GD is the gamma delta cluster. I have virtual machines on both these clusters. And what I'm actually going to do, you can do this both through the UI or through PowerShell, but what I'm going to do would be a little bit finicky if you had to watch me do all the clicking. So I have a script here, and what this script is going to do is it's going to take this virtual machine, the Windows server to move, and it's going to move it through every node in every cluster. So let's set up our workload. I've got my ping running. I've got my file copy. One day I need to figure out how to script placement and sizing of windows so that these just come up in the right place. So the first thing I'm going to do is I'm going to do a migration inside the cluster from alpha to beta. And by the way, this script is just all using the inbox PowerShell commandlets. And this is going to be very quick because it's just it's using CSV, and as you can see, we switched it across to beta. We dropped one ping. So now, for the fun one, we're going to move from beta to gamma, which is going to be moving between these two clusters. So what we actually do is we're going to remove the virtual machine from this cluster. Then we're going to do a shared nothing live migration between the two clusters, and we're going to add it to the gamma delta cluster. And the key thing is, at no stage do we need to turn off the virtual machine for any of these operations. So you can see here that the virtual machine has disappeared from the alpha beta cluster. And if I bring up here, you can see that the virtual machine is actually currently on beta, and we're in the process of migrating to the other cluster. Now, this is going to be a slightly longer migration because this time we are moving the storage. So we're actually setting up the storage mirror between two CSV volumes on different clusters right now. So there are a couple of things I'd like to talk about while this is happening. The first one is, why do you care about this? Well, we've been announcing, hey, we support huge clusters now. We support up to 64-node clusters. And I know some people are doing that. But I also talk to many people who, for different reasons, end up running multiple smaller clusters in their environment. And there are different reasons for doing that. And that's fine, too, and supported. But what ends up happening in those environments is they really enjoy the mobility inside the cluster, but it's like the VMs are stuck in this little pool now, and they can't get good utilization out of their entire data center. Well, now, in that configuration, you can continue to have your great, quick mobility inside the cluster, but then, if you need to do some manual load balancing across clusters, you can do that. So we've just gone across, we've dropped a single ping, and we're now adding that virtual machine to the cluster. If I go back to Cluster Manager, I go over to Gamma Delta, we're going to see there's the Windows server to move. And the final step is to move it from Gamma to Delta, complete the tour of the 4 servers. And once again, this is going to be a quick migration because we're on CSV. And it's gone across to Delta, and 1 ping dropped. So there we are. 2 clusters, 4 servers, virtual machine moved across all of them, network connectivity maintained the whole time. Both clusters are a member of the same domain. But what this says is there isn't a scenario now where you can't move a VM. And the final thing that I'm going to point out is I'm going to run my cleanup script here, which actually migrates it back to alpha so I can do this demo again. I never turn this VM off. I actually checked the uptime of this system this morning as I was practicing the demo. I've practiced this demo like dozens of times over the last couple of days. This VM's been running for about 2 weeks now while I practice this demo. So that's the other thing is you don't need to turn VMs off anymore. And I just think that's really amazing. So, we've had lots of fun positives, so let's have some boring negative discussion. Let's have a bit of a reality check. One of the biggest challenges that you need to be thinking about, and one of the biggest things you need to keep in your mind as you're thinking about this and thinking, hey, this is cool, I want to take advantage of this in my environment, is you need to be aware of how to do this securely and how to work with the security system that exists in Windows to design the best system for your environment. So there are a couple of things to know about security and configuring live migration securely. First, as an obvious best practice, we do not enable live migration by default out of the box. You put Hyper-V on a server, we don't turn live migration on. We want that to be an explicit decision. Because turning live migration on, we do start listening on a TCP port for live migration requests. That obviously increases attack surface. So we've done a lot of testing, but standard practice, don't open ports unless you need to. So if you're going to want to use this functionality, you need to come in here and turn it on. I'll talk a bit more about the CRED SSP and Kerberos options a little bit later on in the deck. But here I'd like to talk about this option here. One of the things that we do really, really recommend is that you configure a secure network for live migration traffic, and that you tell configure Hyper-V to use that as your network. We do support you saying, hey, use any available network, and really, unless you're in a test lab, please don't do that. The key thing to understand is when we're doing live migration, in order to do it with zero downtime, we have to get the data over as fast as possible. And part of getting it over there as fast as possible, we do not encrypt it. That would slow down the live migration process. And it's the memory content of the virtual machine. So there may be confidential data in there. So there are two options that we recommend. The first and simplest one for most people is just use a physically secure network and ensure that your live migration always goes over a private, physically secure network. The second option is use another form of software to protect that. One of the things we actually talk about is you can use IPsec to protect the live migration network. And I get a lot of questions about, come on, does that really work? I mean, no, IPsec, that's a big, complicated beast, and it adds a lot of overhead. And something I like to point out is at Microsoft, IPsec is turned on all of our corporate networks by default. And sometimes my testers are a little bit lazy. So we actually do more testing of live migration with IPsec enabled than we do with disabled. Because for my test team, if they just throw some boxes together in the office and use the corporate domain, then that was easy, but they're testing with IPsec. They actually have to set up their own test domain in order to test without IPsec. So I can guarantee that, yes, IPsec works, and that's a completely viable option. So those are some things to think about. Sorry, I've just talked about that. The next thing to think about is how you're going to manage security and authentication. And there are some challenges here, and I need to step you through. And I apologize, I know for some of the people in the room this is going to be a bit of Windows Authentication 101. But I also know that there will be enough people here where this will be new that I need to cover it before I jump into the details. So we all understand that when you're using Windows, you sit down at your client computer, you connect to your server, and your credentials are provided to that server so that it can perform actions on your behalf, and it can know what you are and aren't allowed to do. Well, as a security feature of Windows Server, we do not allow that server to then take those credentials and connect somewhere else and continue doing something on your behalf. And by the way, I'll warn you, you're about to see the worst clip art graphics ever, so brace yourself for it. So why do we have this? Because there might be a bad guy. Do you like my bad guy? That came from office.com. I am not an artist. There might be a bad guy, and we don't want it to be possible for him to be able to steal your credentials just because you connected to a server that is compromised. So how does this affect Hyper-V? And how does this affect the mobility scenarios I've been talking about? Well, today what I've effectively been demonstrating is this sort of a configuration. I've been logged into one Hyper-V server, and I've been live migrating virtual machines to the other. And that works fine. I have my client connecting to a server. But what doesn't work is if I connected from another box and tried to initiate this, because then Hyper-V would need to take my credentials. And if you remember, we have that first phase negotiation check where we're seeing, hey, do you have permission on both sides? And setting that up. And we need your credentials on both sides for that to work. And that's not allowed. The other one this one, and we've spent a lot of time talking about this internally, and this is one that I have actually gone to my management chain and said, hey, we need to do a better job of this in the future, because I can guarantee that in 6 months' time, I'm going to be in a server meeting room with the server executives, and they're going to be asking me why we're getting support calls on this. I don't know if you're aware of this. On Windows Server, if you're one of the top support call generators, you get to meet the VPs. It's great. It also affects this scenario, which a lot of people don't think about. So with my Zeta Epsilon setup, I was logged into Zeta. I live migrated a virtual machine to Epsilon. That worked fine. But if I then, in the UI that I was in and was working, if I then just switched over to Epsilon and said, let's move that VM back, it would have failed. And would have failed because even though those are two boxes, from a security perspective, what we see is the server received credentials and now it's trying to use them somewhere else. And we do not allow that by default to protect users from potential malicious servers. So what can you do about this? How do you address this? Well, there are actually a couple of options. The first option is we do allow you to go into Windows Server and say, hey, these servers, for this purpose, can take these people's credentials and reuse them. It's what's called enabling constrained delegation. And I'm going to step through that in a little bit. The other option is you can make it look like you are logged in on the box. I've been doing that today with my demo, in that I've been using remote desktop and connecting to the box. It looks like I'm logged in. You can also do that using PowerShell remoting. And I'll also talk about what that looks like. So enabling constrained delegation. This is something that a lot of people get a bit uncomfortable about when I say, you should enable constrained delegation. And on one hand, here's one page that tells you how to do it, but I'll admit there's a lot of words on that page. But it's actually not that hard. And I went through and I screenshotted this. So this is an Active Directory policy. I go in Active Directory users and computers. I find my server, bring up the properties. I go to the delegation tab here. I select that I want to trust this computer for delegation, and I specify what computers I want to delegate it to. And once I've selected my computer, what you actually want to select, there are two things. There's the Microsoft Virtual System Migration Service and the CIFS service, CIFS. You need to enable both of those. And once you do that, OK. I didn't screenshot the OKs. Then you're up and running, and everything just works. We also have one of the testers on our team, a great guy, Taylor Brown, went through and did some extensive documentation on how to set up constrained delegation, as well as documenting the process. He's also provided some awesome PowerShell scripts that allow you to automate the process. We also have some official documentation up there, and there's the link for that. The other option is PowerShell remoting. Now, the key catch here is it's actually PowerShell remoting with CRED SSP. If you do standard PowerShell remoting, you actually have to do the same constrained delegation steps that I just stepped you through. PowerShell remoting with CRED SSP allows you to do all of the migration stuff without having to go and change policies on Active Directory. And it's actually quite simple to set up. On the server side, you run this one PowerShell commandlet. On the client side, you run this commandlet. And you have to specify the computers that you're delegating to, but that actually does support wildcards. So I set it up in my lab, and I just did star dot and my domain name and said, hey, any machine in my domain, it's fine, go for it. And by the way, this is the method that I use most often in my demos. And all my demo scripts use this method to bring virtual machines back at the end of the demo. And finally, there's remote desktop, which hopefully I don't need to tell anyone here how to set that up and use it. If I do, you might be in the wrong session. So that's live migration. What about storage migration? It's not as sexy as live migration, but it is really, really useful. I like to tell people, when it comes to storage migration, there's the official story about why you want storage migration, and then there's the unofficial story. Or another way, there's the story I would tell a CEO or CIO at a company, and then there's the story for the guy on the forums. So the CIO story is, hey, you have a Hyper-V cluster with a bunch of virtual machines running on a SAN, and you've gone out and you've bought a new SAN because you want to run more virtual machines, and storage migration is going to let you move all those virtual machines from the old SAN to the new SAN and re-provision the old SAN and do it all with zero downtime. And that's true. And the CIO will nod and say, that's good to hear. For the guy on the forums, and I know that some of you might find this hard to believe, but we have seen that sometimes people don't read our documentation. Sometimes they just install the software and start clicking things and get themselves in trouble. And sometimes, rarely, okay, quite often, we get people coming to our forums and going, help, I'm out of space. I've got all these virtual machines, and I need them running now, but I'm out of space. What can I do? Well, storage migration is going to save them all, because it's very easy now to go in and go like, okay, go get a USB drive or go get a remote server, and let's do a storage migration. Let's move those virtual machines around. Let's get the files where they need to be. So how does this work? So here I have a single server, and I have my virtual machine that's running, and it's talking to a virtual hard drive. Key thing to point out, I always get asked this, yes, we only support storage migration if you're using virtual hard drives. So if you're using iSCSI, if you're using virtual fiber channel, we don't support doing storage migration. If you're using pass-through of physical disks, please come up here afterwards, and I will promise not to punch you, but then I will explain why you shouldn't be using it. Please, please, please don't use pass-through of physical disks. Virtual hard drives, they're good. So we have a virtual machine. It's running on a virtual hard drive. And I say, OK, I want to move this over to the destination device. So the first thing we do is we start mirroring write operations. So the virtual machine is still running. Reads and writes are going to the source virtual hard drive. But any new writes start going to the new location as well. Once we start mirroring, then we do a single pass copy, with the exception of we keep track of what things we've already written, so we don't do a double copy. But the bulk of the work for storage migration is a single pass copy. Once we've completed that single pass copy, we just transition over to reading and writing from the destination device, and we remove the source VHD. Something I do like to point out here is we do support storage migration to and from anywhere that we can write a virtual hard drive to. So you can storage migrate from local to SMB, from one SMB server to another SMB server, from local to CSV, from CSV to local, from CSV to SMB, any combination. It's a great way to allow you to reconfigure your system without taking your virtual machines down. So now let's see what that looks like in the UI. No, I'm just smart enough that when I'm presenting in a different town, I put a screenshot of it on my desktop. I was hoping someone would notice that. I got up this morning, I was like, okay, let's go have a look. I actually went to, I clicked on the more themes, and I found there's a Netherlands theme up on the Microsoft site. So yeah, I thought of that one. Thank you for noticing. Okay. So here's my workload. Let's go that set up. Okay, so I'm going to do a storage migration on this virtual machine, and I'll show you the settings first, and I'll show you that this virtual machine is stored on the J drive, and we're going to just do a storage migration to the K drive on the same server. As I mentioned, this could be going to any location, but I'm just keeping this simple today. So once again, I'm going to use the same move wizard that I've been using all day. And this time, instead of saying move the virtual machine, I'm going to say to move the virtual machine storage. Now, you probably noticed I've been skipping over this page quickly in the other slides. We actually provide the same options for storage migration or live migration. We have what I like to call the simple option: take all my stuff, put it here. And I am going to use that today, but I do want to show you the slightly more advanced option in that we allow you to, one, specify different locations for every component of the virtual machine. And if this virtual machine had multiple virtual hard drives, we'd allow you to specify different places for each virtual hard drive. But two, we actually also allow you to select to only move part of a virtual machine. So if you have a situation where you have a large virtual machine with multiple virtual hard drives and you just want to move one of them, that also works. But as I said, I'm going to do the simple option today. Move it to the K drive, and we'll start that running. So two things to point out. First one, this is actually my worst demo for the progress bar being inaccurate. For whatever reason, my development team decided that they would use the same progress bar logic for every form of migration, even though they're all very different. So we'll see what it does for the progress bar. But the second thing is, with a storage migration, I've got my two workloads. But what you're going to see is we're not going to have a dropped ping this time, because the virtual machine actually never moves location. I know for some of you are going, yeah, that's obvious, but I have to talk a lot of people through this. The virtual machine stays in the same location. It's just the storage that's moving around, and there is no interruption to running. So you can see we've completed the storage migration, no dropped ping, the workload's continuing, and if I bring up the settings, we'll see that it's now on the K drive. So that's simple. And once again, here's what the PowerShell command looks like. Very simple PowerShell command. Move my VM to this path. Now, I will say, if you want to see the PowerShell command for moving all the bits to different places, that is easily the most complex PowerShell command I have ever seen. I don't have that in my deck today, but that is quite complicated. We spend a lot of time trying to figure out how to do that one. So the next obvious question that comes up is, okay, but what does this do for my performance? What's the impact of all this fancy storage stuff? So there are a couple of implications and a couple of things to think about. The first one is, how long is it going to take to do a storage migration? And we spent a lot of time looking at this because we didn't want to build this technology and have it take so long that people were going, you know what, screw it. I'm going to shut down the VM and copy the files. That's faster. So we have tried to make it as fast as possible. If you want to get a feeling for how long it'll take, essentially when we do a storage migration, we're doing an unbuffered file copy. Now, if you go into Windows Explorer and just drag and drop a file, that's a buffered file copy. We're using all sorts of memory cache and so on, so that will be faster than a storage migration. If you want to get a feel for what an unbuffered file copy feels like on a system, xcopy/j, or I've actually found that robocopy/j also does an unbuffered file copy. And that's actually, by the way, if you're using xcopy or robocopy, that's recommended for copying large files like VHDs, because otherwise Windows uses huge amounts of memory for the file cache. So you can grab your computer today and do an xcopy/j, and you'll see what sort of time we're talking about. The other performance impact is, what does it do for I/O churn? And, well, the simple fact of the matter is it's a large file copy. And it basically does about what you would expect to see if you did a large file copy. Now, in most cases, we actually expect that storage migration won't have a big impact on the system. And the reason for that is because if you're following the scenario we designed it for, where you're moving your storage from one device to another device, well, the extra churn that we're creating is going to be mostly on the device that you're moving to. On the other hand, and I'm a little bit nervous telling this story because I can't remember who it was and they might be in the audience. But I'm going to tell the story anyway. There was a certain journalist who came up to me at one of our launch events and said, hey, I was playing with the storage migration, and when I did it, wow, the performance of my system was terrible. Like, all my virtual machines stopped responding. Like, is there a bug here? And I was like, well, that sounds bad. Like, can I have a look? Can you tell me about this? So we start talking, and he was storage migrating a running virtual machine from one folder on his 5400 RPM laptop drive to another folder on the same drive, while that drive was running 3 other VMs. And you'll never believe this, but it couldn't keep up. So yes, think about the fact that it's a large file copy, think about what your storage is capable of, and keep that in mind. And for that reason, by the way, we do actually have a setting that allows you to limit the number of simultaneous storage migrations, so that if you're worried about people unwittingly overriding the I/O, you can go in and configure this. We have set it to 2 by default, so that we can be nice and safe. We do not have a supported limit for this, though technically in the platform we only let you set it up to 57,000 concurrent storage migrations. So if that's a problem for you, please let me know. So the final thing that I'm going to talk about today is importing a virtual machine. This is kind of the most basic form of virtual machine mobility. You know, forget all this fancy online stuff. No, I've got some VMs on a disk. How do I get them from here to there? And I'm going to start by saying this is something that just sucks today. And I'm truly sorry for that, because it's actually my fault that it sucks today. Who here has had this experience with Hyper-V Server 2008 R2, where something's happened, disk corrupted, problem with the server, and you've ended up with a disk that has some XML files, VHD files, and you just need to hook it back up to Hyper-V. Can I see a show of hands? Yeah, doesn't work, does it? You know, that's, and as I said, I'm sorry, that's my fault. You know, that's a story that we've heard many times. You know, and it's like, oh, you need to export the virtual machine first. And it's like, well, it's too late. The system doesn't run anymore. The other thing, let's have a show of hands. How many people here have actually tried to export a virtual machine from one location and import it on another one with 2008 R2? Okay, I'd say just over a third. Now, of you people who showed your hands, how many of you, when you did that, was the resulting virtual machine exactly what you expected? Oh, 3, 4, 7. That's the most hands I've ever seen for that question. Once again, my fault, but let me explain. I like to compare export and import in Windows Server 2008 R2 to, it's like watching a zombie walk down the road. Because get this mental image. You have a zombie, he's walking down the road, and as he's walking, he's dropping body parts. But he's still walking. And that's what, in Windows Server 2008 R2, that's what importing a virtual machine is like. Because what happens is when we're importing a virtual machine, if there's any part of the virtual machine that we don't understand, we just throw it away. This network adapter is connected to a switch that we don't know. Okay, disconnected. Most people have hit that one, but there are some really fun ones in there, like, this VM has more memory than that is in this box. Okay, we'll set it to 512. This VM has more CPUs than we can support. 1. It's pointing to a VHD that's missing. Right, go on. So we will get to the end of it. And by the way, import will never fail. It will always succeed. You may have nothing that you started with. You may end up with a VM that's completely different and useless, but we all say import succeeded. So it's not useful. So we spent a lot of time working on this because, as I said, this is the basics of mobility. So the two big things that we did. The first thing was we said, okay, just give us your XML file. Get rid of export. You give us an XML file, we'll hook it up. And we even support that if it's an XML file from Windows Server 2008 R2. Just bring it, hook it up to 2012. I can't wait until I have the next person come to me and say, hey, I'm using Server 2008 R2 and the system crashed and I've got a bunch of XML files, what can I do? Because my answer is going to be, install Server 2012. And by the way, we actually still have an export button in our UI. All it does is copy the files. It's just there as a convenience. The second thing that we've done is we've provided an experience for allowing you to go in and fix up configuration issues and know what's happening so that there are no unpleasant surprises at the end of the day when you're importing a virtual machine. So I'm going to demo what this new experience looks like. Okay. So I'm going to import a virtual machine, but I've tried to make this as realistic as possible because when most people have their disk that they need to import a VM from, they don't just have one XML file on there, they have a bunch. And as anyone who's had a disk full of XML files know, they're intuitively named by the internal identifier. And I'm sure that you all know the GUID that identifies your virtual machines by the back of your hand, right? I could walk up to one of you and say, what GUIDs do your virtual machines use? And you'd just start rattling it off, wouldn't you? No, you wouldn't. So the first thing that we've done, we say, give us the folder where your XML files are. And I've got a couple of XML files in this folder. And to start with, we'll parse those files, we'll find the virtual machine names, and we'll give you a nice human-readable list. So here I've got a couple of virtual machines, and I'm going to choose virtual machine to import. The next thing we've done is, in the past, we had copy and move. We've added a third option, which a lot of people ask for, which we're calling register. And this is, I've put all the files where I want them. Leave them alone, and just hook it up to Hyper-V, please. So I'm going to select copy today simply because I have to do this demo over and over and over again. So I want to make a copy of the virtual machine. Now, because I've selected copy, we're now going to come up and say, hey, where am I going to copy all the bits to, please? I'm going to select the defaults, but you could come through here and say, hey, here's where I want to store all the different bits of the virtual machine. We're also going to ask, where are the virtual hard drives for this virtual machine? Where should I look for them? By default, we will look where the XML file is, but we also let you say, hey, I put the VHDs over in a different location. And we're going to ask, where do you want to copy the VHDs to? But now for the fun bit, because I'm going to hit next, we're actually going to take this XML file, compare it against the system, and come up with a detailed assessment of everything that doesn't work on the system. And for everything that doesn't work, we're going to provide a page that tells you what doesn't work, what the setting was, and what the setting can be. And we're going to let you choose what the setting should be. So I made this VM so it had two issues, the processor and the networking. But literally any part of the virtual machine setting, we have fix-up pages for it now that allow you to correct it. So I'm going to say, let's do 2 virtual processors. This one I like. Now, this is something very small, but I'm sure that many of you have had this experience. You've exported a virtual machine. You've imported it on another computer. We couldn't find the virtual switches, so they've been set to disconnected. And you've sat there at the VM settings, looking at it, going, I have two network adapters. They're disconnected. One of these goes to the public network, and one of them goes to the private one. And I don't know which one is which. That's awful. You know, you basically have to gamble. Hope I get this right. So as you can see here, not only do we say, hey, it's not connected, but we say, here's the name of the switch that this network adapter was looking for. This network adapter was connected to a switch called public, so that I can look at that and go, oh yeah, okay, that's good. That one is safe to connect to my public network. So I'm going to connect it to virtual switch. So go through, make all those changes, and it's going to import that virtual machine. And if I bring up the settings, you're going to see it's got two virtual processors like I asked. It's connected to virtual switch like I asked. No surprises whatsoever. Exactly what I expected to happen. So importing a virtual machine finally works the way people expect it to work. Novel idea. So I've been showing the PowerShell for each of the commands, and it's been nice and simple. Do apologize, this is not a simple PowerShell command, but I will show you what the process looks like. We've made sure that everything does work through PowerShell. PowerShell doesn't have like a wizard as such, which makes things kind of interesting. So here's what would happen if I tried to import that virtual machine. So I'd try to import the virtual machine, and I'd get a nice error message saying, unable to import the virtual machine due to configuration errors. Please use compare VM. Okay. So I'm going to use compare VM, and compare VM returns a .NET object that we call a virtual machine compatibility report. So I basically, by the way, I'm using exactly the same syntax for compare VM as I use for import VM, and I'm storing the returned object in my VM compat report. And there are a couple of key things here. You can actually see down the bottom here that we have incompatibilities. I can actually, using PowerShell, I can look at those incompatibilities. So incompatibilities, look at the messages, can't find switch, number of processors are wrong. So the nice thing is, the compatibility report actually has the virtual machine object hanging off of it. So what I can do is, using all of our standard PowerShell commandlets, I can go in and change the virtual machine object to look like I want it to. So here I am, set VM processor, but I'm passing it the compatibility report VM, set it to 2. In this example, I actually disconnect the network adapter. And once I've fixed up the incompatibilities on the report, then I can import VM, my compat report, and it will go ahead and succeed. So a little bit more detailed, but the key thing is you can do it through UI, you can do it through PowerShell. So the final thing, and as I told the people in the speaker room who were fiddling over all the annoying evaluation slides, they were spending a lot of time on my deck changing all the evaluation slides. And I said, you're wasting your time because I'm going to stop on my slide and no one's going to see those. The final slide, because I'm not going to go through all the silly evaluation slides, is everyone's favorite, a big table of frowny and smiley faces. I get a lot of questions from people looking at Server 2012, looking at all the things we've done, and trying to figure out, wait, like, does Hyper-V replica mean that I no longer have to do backup? Does shared nothing live migration mean that I no longer need to do clustering? And the answer is no. All of these technologies address different needs and different pain points. I've provided a nice little table here. I always get asked this. I have a couple of straight faces in there. I put the straight face in when there are cases where, like, sometimes in some scenarios you could use it for this, but not all the time. So I'm sure that we are going to have customers who end up deciding that in order to do what they want to do, they need to use all these technologies. But I'm also sure that more commonly, people are going to be picking and choosing the technology that makes the most sense for their needs. So they'll be providing this deck afterwards. But just important to know, there's no overlapping technology here. Technology solves different problems, and you need to be thinking about what you want to get out of it. So with that in mind, I'd like to thank you for coming last day. I would ask, please do fill out the eval sessions. I could use some schmaltzy thing like we really care, but the truth is we have a competition behind the scenes, and it's important to be able to lord it over your colleagues and say, yes, I got a better score. So please help me to be a poor winner. And with that in mind, do we have any questions? So the question is, we're trying to find the PowerShell commands for configuring the live migration settings on cluster. And the answer is, I honestly don't know. I'll know they'll exist, and I know that you know my email address. So can you shoot me an email, and I will, A, get you an answer, and to the rest of the room, I promise that I'll put that up as a blog post. Because, hey, if you don't know and I don't know, then it would be a good thing to put on the blog. So the question is, does Hyper-V Replica work between two clusters? Absolutely. We did a lot of work to make sure it works. It's actually something that we support replicating from a cluster to a cluster, between two clusters. It all works. It's something that I'm really passionate about, and I push hard on the team, is I never, ever, ever want to see us release a new feature where it only works if you turn off a bunch of other features. So we do a lot of work to make sure that all of our technologies work together. For instance, live migration and replica work together. You can live migrate a VM around and replica still continues working. Storage migration and replica work together. It all works.
Is there a tool to copy the security settings which are on the virtual machine files? And I mean the virtual machine group.
So the question is there a tool to copy the virtual machine group?
No,
the files.
Virtual machine files, because when you add them to a virtual to a Hyper-V environment, there are some special anti-virtual machine group added.
Okay. So the question is, when I do, you're talking about the import scenario. Yeah, when I do the virtual machine copy, is there a tool to fix up the permissions? We have the virtual machines group. And there are two answers to that. The first answer is, no, there isn't a tool because we make it all work for you. You don't have to worry about that. In import and in live migration, storage migration, we fix up all the echoes for you. The second answer is, the reason why it's confused is we've actually made that even harder. And we don't have a virtual machines group anymore. We actually create a special type of user account per virtual machine. It's a nice little security feature, but it does make the ACLs just awesomely hard to read when you look at the files for the virtual machine.
I tried iCackles, and
yeah.
It's very complex.
Yeah, trust me, we made it even more complex in 2012. You will be glad that we do that work for you. So any other questions? I don't see any hands, so I'm going to turn on the microphone, which means half a dozen of you are going to come up and ask me questions. But once again, thank you for your time.